Okay, guys, we are starting chapter 3. We're all done now with 2 units of college algebra. Moving on to polynomials, and the first type of polynomial we're going to study is, of course, the quadratic, the second degree polynomial. Just like with equations of lines, the quadratic equation has 2 different forms. We have vertex form and standard form. Okay, just like with equations of lines, we have slope-intercept in standard form. It's very similar. Okay, they're still the same parabola that they're gonna, the graph would be the same, but they're written in different forms. Let's see, the vertex form is y equals a times x minus h squared plus k. The vertex of this parabola will be at the point h comma k. That's where the vertex will be. Notice the minus is part of the expression. So if I have x plus 3, for example, the vertex would be at -3 comma whatever k is. Okay, if a is positive, then the parabola opens up. If a is negative, then the parabola is reflected across the x-axis and opens down. All right? If a is bigger than 1, then you get a very, very thin-looking parabola. Okay, it's very skinny. It's stretched towards the y-axis. If a is a fraction between 0 and 1, okay, if the absolute, I should say the absolute value of a, because if a is like -2, that's going to be skinny, but it's just going to be pointing downwards. And if the absolute value of a is between 0 and 1, if it's a fraction, like a half or 2/3, then it's going to be wider. Okay, just little notes that you can jot down. So for example, let's look at this one. Right away, I look at this. It's in vertex form. So happy I can just tell you right away that the vertex is at 3, -5. So nice. Axis of symmetry is that line that cuts the parabola right in half. And it's always x equals the x coordinate. Okay, the line x equals 3, that vertical line will cut my parabola in half. That's where the symmetry happens, right at the line x equals 3. The y-intercept, not as easy to find, is it? I'm going to put 0 in for x. When I do that, -3 squared is 9. 2 times 9 is 18. So it looks like the y-intercept is going to be at the point 0, 13. I'm not even going to be able to graph that on my on my little coordinate system down here. The range, well, let's look at it. It's opening up because a is positive. It's very skinny. The vertex is at 3, -5. Sometimes I graph it before I even think about the range. Even if I just have to scratch it off to the side, I know the vertex is at 3, -5. There we go. I know it goes through 0, 13, 10, 11, 12, somewhere up here. Because x equals 3, this line right here is going to cut my parabola in half. I know that, let's see, 0 is 3 units away from 3. So 3 units away in the other direction at 6, 13. I'm also going to have a point. So anyway, I can kind of have an idea. The range is what kind of y values are coming out. Notice I'm not asking for the domain. The domain of a quadratic is all reals, always. Okay, I can stick any number I want in here. The range, however, if I look at my vertex, that's the smallest that y will ever be. My range is from the y coordinate of my vertex to infinity. In this case, since I'm opening up. Okay, now where am I increasing? Well, from this point forward, and that happens right at the vertex of 3. So I am increasing from 3 to infinity. Where am I decreasing? Right here at this part of the graph, and that's from -infinity up till I hit 3. Okay? That's a parabola written that way. Now, standard form is y equals ax squared plus bx plus c. Okay? If something's written in standard form, a is still telling me the same thing as it tells me over here. If it's positive, it's opening up. If it's negative, it's opening down. Okay, so I can still have that same idea. The vertex, however, guys, the x-coordinate of the vertex is always going to be the opposite of b over twice a. Now, you could find that by completing the square over and over again, or you can memorize that that's where the vertex happens. The opposite of b divided by twice a. The axis of symmetry, of course, will be x equals that x coordinate, just like it was x equals this x coordinate here. Okay, so opposite of b over twice a, in this case, oh, I should have written that up here. The x coordinate is the opposite of b over twice a. So I guess down here, I was actually asking for this exact vertex. The vertex here, I don't really know the y-coordinate, but I know the x-coordinate is the opposite of b, that'll be 12, over 2 times 2, or 4. So the vertex is at 3 something. I at least know that. Okay, now I don't know what the y-coordinate is, but here's my equation. I can find the y-coordinate if I know any x-coordinate. So I am just going to go off to the side now that I know that 3 is the x-coordinate. I'll say 2 times 3 squared minus 12 times 3 plus 13. That gives me, what, 3 squared is 9 times 2, 18, minus 36 plus 13. 18 minus 36 is negative 18, plus 13 is 5. So my vertex is at 3, negative 5. Negative 18 plus 13 is negative 5. Notice it's the same parabola. I just gave you the same parabola written in a different form. This one was so easy to see the vertex. This one not so easy. I had to take the opposite of b, 12, divided by twice a, 4, to get the x-coordinate. Then I had to put that x-coordinate back in my equation. The axis of symmetry is x equals whatever the x-coordinate of the vertex is, which happens to be 3. The y-intercept, a little easier to find. I put 0 in for x. I can see it's 13. Okay, a little bit easier than over here, having to go through that. Some things are easier in one form than the other. The range, I can tell you again, I see that I might even graph it a while. What do I have? 0, 13, and 3, negative 5. It's the same graph. 0, 13. So I know that 6, 13 is there as well. Oopsies. I'm sorry. Please draw it better. Okay. So we get our graph. You guys make your notes a lot better than me, I hope. Pause me and, make it neat. The range, the y coordinates are all bigger than negative 5. So I'm going to say negative 5 to infinity. And of course, my increasing and decreasing intervals are the same. It's increasing from 3 to infinity. It's decreasing from negative infinity to 3. You just look right here at the axis of symmetry, and that'll cut it in half to increasing and decreasing. Okay, so those are our two forms. Vertex form, standard form. Process is a little different depending on what form we have. However, these are still the same things I'm going to ask for. What's the vertex? What's the axis of symmetry? Where's it crossing the y-axis? What's the range? Where am I increasing? Where am I decreasing? Depending on what form you're given, they will decide, the process. Okay? So let's find the vertex of each of these. Okay? When it's given in vertex form, I just want to make sure you're able to find it. Okay? This 3 doesn't mean anything to the vertex. The vertex here is 1, 4. This is going to open up because 3 is positive. the next vertex. Let's look carefully. -2, +5. Oh, gosh, sorry. -2, 5 is the vertex for that one. And then if I want to know which way it opens, it's not asking me that, but might as well explore that a little bit. I notice it's -0.5. So A is -0.5, so it's going to open down. It's going to be a little wider than my normal parabola. This one's going to be a little skinnier than my normal parabola. The next one, the vertex here is going to be +4, -6. Because of this -2, I'm going to open down. And 2 is, bigger than 1, so it's going to be a little skinnier. Not quite as skinny as the 3, but, skinny. The vertex here, oh sugars, I'm going to have to do the opposite of B divided by 2 times A. 2 times 3 is 6. I don't know the y coordinate, but I know that my x coordinate of my vertex is -1. To find the y coordinate, I'm going to put -1 in for x. -1 squared is 1. 6 times -1 is -6. So I have 3 plus -6. -3 minus 1, what's that? -4. So the vertex here is -1, -4. It's opening up and very skinny. Okay, 3 is positive. All right. So let's look at this next one. What do we know about this graph? I love when it's in vertex form. I can see the vertex right away. 2, -1 is the vertex. It opens down because the 3 is negative. It's a little bit skinny. Okay. That's all I can tell right now. I'm just looking and I know 2, -1's the vertex. It's opening down and it's skinny. I might find the y-intercept by putting 0 in for x. 0 minus 2 is -2. -2 squared is 4. -3 times 4 is -12. Minus 1 is -13. Goodness sakes, I'm always 10, 11, 12. Sorry, I gave you things that didn't fit. So because x equals 2 is my axis of symmetry, I know that since 2 away gave me -13, 2 away in the other direction is also going to give me -13. So I can draw a nice little sketch of what this graph looks like. Looking at it then, I know the range, the y values are going to be -infinity up to -1. I'm never going to be bigger than -1. Okay, that'll be my range. I know it's increasing from -infinity up until x is 2. We're looking at the x coordinate for that. From the time x is -infinity until it hits 2, my graph was increasing. I'm decreasing then from 2 to infinity. Right? The increasing, decreasing goes from the x-axis. Okay? How about this one? Not as hard to tell, is it? Sometimes when I see one in standard form, I right away just stick 0 in. I can see 0, -15 is going to be a point on my graph. I know it opens up. The vertex is the opposite of B over twice A, something. So the opposite of B is 2 divided by 2 times 1. So I have 1 something for my vertex. Yay. 1, I'm going to put 1 in. 1 minus 2 is -1. Minus 15 is -16. So my vertex is at 1, -16. Sorry that you can't graph that. That's just 9, 10, 11, 12, 13, 14, 15, 16. 1, -16, 0, 15. Okay. I can at least see that it's a nice little parabola opening up down here. Okay, and at least I can have a graph of it. The range, of course, would be from -16 up to infinity. Okay?